Hello students, in this video we'll prove Rabes' test for convergence of an infinite series. Let's be given a sequence AK such that the ratio AK plus 1 over AK is less than or equal to 1 minus P over K plus a constant C. So suppose we can do this for all K, for K large. Then Rabes' test says that if P is larger than 1, then the series converges. Excellent. So this is an extension of the ratio test, because what the ratio test says, now what would the ratio test say? Is k is going to infinity, what's that saying? As k goes to infinity, this term is going to 0. So this includes the case when the ratio is going to 1. And when this ratio goes to 1, the ratio test is inconclusive. Whereas in this case, with this estimate over here, then Rabes' test will allow us to conclude that it does in fact converge. And so let's see how we prove this. So what we're going to do is the following. Let's define. So we have this estimate. So define a new sequence. Define BK to be K plus C minus 1. Okay, so I'm going to construct the sequence BK. So in other words, BK is growing like at a rate of K basically, right? Okay, good. All right, and so now what we're going to do is we're going to note that now we're going to consider this ratio over here. So let's look at the ratio. Well, what do we have over here? We have this, what will BK plus 1 be? This is going to imply that BK plus 1 is going to be just K plus C, right? So if we look at this ratio over here, then I have that AK. So this 1 minus P over K plus C is less than or equal to, by the binomial theorem, 1 minus 1 over K plus C to the power P. And so this estimate follows from the binomial theorem because those are just the first two terms that we get in the binomial expansion. They have more terms in the expansion. So the binomial expansion gives me this. It's like Bernoulli's inequality. And so now let's rearrange this and see what we get. So what will happen over here is that this is going to be equal to what? This is going to be K plus C minus 1. So it's going to be K plus C minus 1 over K plus C to the power P, right? And so what this is that this expression over here, by rearranging this expression, is exactly equal to what? Is exactly less than or equal to, this is going to be the numerator is going to be my BK, the denominator is going to be my BK plus 1 to the power P. And so we've just established over here, that our AK plus 1 over AK is less than or equal to this expression, okay? So now, if I rearrange that, what does that say? Well, that says that AK, so this implies that AK plus 1 times BK plus 1 to the power P is less than or equal to AK times BK to the power P. So the sequence BK to the P is a decreasing sequence, right? So now we can consider this sequence over here CK. So CK is going to be AK times BK to the P is decreasing. Okay, and so what that says that eventually I can let's say that this is less than or equal to some constant eventually. So for that, therefore, for large K, we have that AK. I have the absolute value around here as well, right? AK times, and I need my absolute values over here too. Absolute value. AK is less than or equal to a constant C, let's call it constant M, times BK to the negative 1. So BK to the negative P over there, like so. And so it is BK to the negative P. BK to the negative P, and I need to make sure K is large enough so this quantity is non-negative as well, right? To make sure this makes sense, so it's not 0. So that's easy to make happen though. So this exactly looks like what? This looks like M over k minus c plus 1 to the power p. And so this is a p series over here, so I've just bounded ak by a p series. So the ak absolutely converges, hence our sequence ak converges. Because I've bound, its absolute value of these terms are bounded by a p series, and p is bigger than 1, we're assuming. So p bigger than 1 implies that this is going to converge over here. Now, a classic example of this is the following. So let me consider this series over here. So if we look at the sum, k goes from 1 to infinity. Let's do this. The terms are going to have the following form. The ultimate terms are going to look like a 2k minus 1 over 2k plus 2. That's the general form of these terms over here. So when I plug in k equals 1, I'm going to have a 1 over 4. When k is equal to 2 over here, I'm going to have a 3 over 6. So I'm going to multiply all these numbers. When k is equal to 3, I'm going to have a 5 over 8. 5 over 8. And these numbers just keep multiplying like that. Now, of course, if I look at the ratio of any two of these terms, so this is my term over here, ak. If that's my ak, then what's ak plus 1? So the ratio of ak plus 1 and ak is going to be what? Well, ak and ak plus 1 share all the same terms down to the very, very last one, right? So all these things are going to cancel. So in other words, the ak plus 1 has all of these previous terms, and the next term is going to be what? The next term is going to be exactly when k is equal to 1 over here. So it's going to turn to a 2 times k plus 1, 2k plus 1 minus 1 over 2k plus 1 plus 2. And that's going to be equal to what? It's going to be 2k plus 1 over 2k plus 4. 2k plus 4. So what happens as k goes to infinity? As k goes to infinity, this expression is tending to 1, so the ratio test is going to fail in this example. So ratio test fails. But let me do that division over there. So I'm going to divide this over here. So what I can do is I can write this over here, that 2k plus 1, but notice that 2k plus 1 is really 2k plus 4 minus 3, right? Over here. And then I have a 2k plus 4. And so this is 1 minus 3 over 2k plus 4. And the last step is to multiply the top and bottom of this by 1/2. 1/2 and then 1/2. That doesn't change the fraction at all. But this becomes what? 1 minus 1.5, because that's 3/2. And then in the denominator we have a k plus 2. So over here my p is equal to 1.5, my c is equal to 2, and therefore by Rabes test this series converges over here. So we've been proving by Rabes test that this is going to converge. So this thing, when the ratio test fails, we know by Rabes test this series converges. Thank you very much.